Our topic is rational function. So what is rational function?
A rational function is any function that can be defined by a rational fraction, which is an algebraic fraction such that both the numerator and denominator are polynomials.
Rational function follow this form. F of x equals p of x over q of x. We can also write it in this form. So instead of writing f of x, we can write it as y. So that's the output of a function. Here, p of x and q of x are polynomial functions, and very important for rational function, that the denominator or q of x must not be equal to 0. It's not a zero function if the denominator is 0, then it will be undefined. So that's why it must not be equal to 0. Since we mentioned that p of x and q of x are polynomial functions, let's have a run-through on the polynomial function. Let's try to look at some example and let's identify if it's a polynomial function or not. How about this? Your answer would be a yes or a no. Is this a polynomial? Recall your junior high school mathematics. Feel free to pause this video, identify if this is a polynomial function or not. And the answer is, it's a yes. It's definitely a polynomial function. It follows the form of the polynomial function. And aside from that, let's identify its part. It has the following. The first one is the exponents. So aside from that, we also have here exponents of 5x, which is here 1. Then those are the terms. And each terms consists a coefficient like 5, at the same time a variable like this, which is x. You also have 10 as the constant. So these are the parts of polynomial function. You have the terms, you have the coefficient and variable per term. You also have a constant and the exponent arranged in the decreasing order. So that's it. Let's proceed to the next example. Identify if this is a polynomial function or not. And let's reveal. This one, it's a no. Why? It's because of this one. If the given mathematical has a negative exponent in this variable, then that is not considered as polynomial. It's not a polynomial when you divide it by a variable, so take note of that. How about this? I'll give you a time. And the answer is still no. Exactly the same reasoning in the previous example. Since we already have x in the denominator, the presence of that means that we are dividing it by a variable of x, so that makes it not a polynomial function. How about this last example? Square root of x over 5. Yes or no? And the answer is, that is not a polynomial function. If you see a radical sign, it means that the given is not a polynomial function. So remember, negative or divided by a variable, or when you see the radical sign, those are the clues that those given are not polynomials. I believe that we are ready. So this topic will introduce you to word problems that involves rational function. So allow me to read the problem. Jonathan can finish a job in 3 hours working alone, while Lucas can finish the same job in 5 hours working. How long will it take both people to finish the job working together? You may pause this video, read again the problem, and understand. Let's continue. Now, based on that problem, I prepared 5 steps on your guide in solving work problems that involves rational function. So the first one is step 1. That's provide a given. Let's identify the given. At the same time, identify or determine what is being asked. Jonathan can finish that for 3 hours alone, while Lucas can do the same job in 5 hours. So that would be our main given. Jonathan for 3 hours, Lucas for 5 hours. Then, what is being asked? How long will it take both people to finish the job working together? So, that's for both. That is why we have written here both is equal to x hours. I'm using the variable x, meaning it's the unknown rate for both people to be working on.
Let's proceed to step 2. Let us express the given in terms of rate. So let's start with Jonathan. Jonathan can work alone in 3 hours. So the rate there is 1 work per 3 hours. So in fraction, that's 1 over 3. Let's proceed to Lucas. Same manner, we only have 1 work over 5 hours, which is equivalent to 1 over 5. And for both, we'll have 1 work together, that will be the rate for both. That's x hours, 1 work over x hours, so that's equals to 1 over x. So these are now the representation of the given in terms of its rate. Let's continue to step 3. Since we already have the information for Jonathan, Lucas, and both expressed in rates, we are going to add the rate of Jonathan plus the rate of Lucas will give us the rate of both. That's 1 over x. I repeat, the rate of Jonathan, 1 over 3, will be added to the rate of Lucas, 1 over 5. For both, that will be equal to, again, the sum of the two will give us the rate of both, that's 1 over x. Step 4. We are going to combine. So we are going to combine by recalling the one that we've used for the least common denominator earlier. So we're going to list the common multiples right here in this table. I prepared here 5 rows. And by the way, if you already have mastered the multiplication table, then there is no problem. This one is only for the one who want to refresh their minds on how to get the LCD. Let's now continue. Here we have 3. We are going to multiply that to 1, 2, 3, 4, and 5. So it will give us 3, 6, 9, 12, and 15. Again, we just multiplied 3 to each of the number. Let's proceed to the next denominator. That's 5, so times 1, 5, times 2, 10, 15, 20, and 25. There. So let's look for least common multiple. And here, that's 15. So that means 15 will be our new denominator. Our next step is we are going to multiply the given by this number. You need to look at the number right here on the table. So here, if you're going to focus on 3, you need to look at this first column. To get 15, you need to multiply that by 5, right? So meaning, here you're going to multiply that 1 by 5, like this. And for the second fraction, 1 over 5, that will be for the second column. To get 15, we multiply that by 3. So here, you will do the same thing. You will multiply that by 3, like this. After that, we're going to multiply numerators and denominators to get the fraction. So to get product of the fraction, so 5 times 1 will give us 5. 5 times 3, that's the new denominator, which is 15. Added to 1 times 3 is obviously, that's 3. Then 5 times 3 will also give you 15. And just copy 1 over x. After that, we can already get the sum of this. 5 plus 3 will give us 8 over 15. I copied equals 1 over x, that's why we have it here. Now, on this part, we will be using cross multiplication. Let's multiply 8 and x, and 15 will be multiplied to 1. So 8 times x will give us 8x, and 15 times 1 will give us 15. We're almost there. We are going to look for the value of x since there is still a coefficient beside our variable. We are going to find a way to eliminate the coefficient, and to do that, we are going to divide both sides by 8 so that we can cancel that one out and we will be left with our variable, which is x. That's our main objective. The answer is now 15 over 8. We can write that in mixed number, that's 1, and 7 over 8. That's also equal to the decimal form 1.875. What's the meaning of this?
Let's proceed to step number 5. You are going to express your answer sentence form to answer the question earlier. So here, the value of 1.875 is the number of hours. So the final answer is, it will take 1.875 hours to finish the job if Jonathan and Lucas will work together. So that's it. We are done for our lesson about rational function. I hope we're able to achieve all the objective for this video.